Well, hey, look at that, a scene change. Let's go ahead and see if we can try some sample problems on 6.1 and see if we can make any headway. So the first problem we run into will ask if two line segments are equivalent. Specifically, they'll ask if A, B, and the segment composed of points A, B, and points C, D are equivalent. And to really just get an idea, let's quickly just make a graph to see what this looks like. So I'll draw axes. And drawing pictures is never a bad idea when you're trying to figure out what to do. So we'll draw some axes here. See if I can make my line straight. Okay, so we'll start with point A is 3, 1. So we'll go 3, 1. That's point A. Point B is negative 2, 6. Negative 2, 1, 2, 3, 4, 5, 6. So from point A to point B, we have a vector that looks kind of like this. So vector AB looks something along those lines. Vector CD starts at 1, negative 3. So that's 1, negative 3. That's point C. And point D is negative 4, 2. So we'll go to negative 4, 2. And we'll draw a line. And it goes from C to D, so the arrow goes upwards like that. And so you can see visually, they look kind of similar. They look as if they could be equivalent. They kind of go in the same direction, and they seem to be about the same size. So they're probably equivalent, but we'll want to confirm it just in case. And here's a rigorous way to confirm it. I'm going to add values I'm going to add some sort of number to some sort of x value to A and B to see if I can get the x values in C and D. So here's one thing I can do. I know that A equals 3, 1, and B equals negative 2, 6. And I want them to become the same. I want to translate AB to CD. And I can do that by adding x values to both and y values to both. C equals 1, negative 3, and D equals negative 4, 2. Okay, so if they're equivalent, I should be able to add some number to A and turn A into C, and to add some value to B, turn B into D. So let's go ahead and try to add, let's see, if I wanted to turn the x value of A into C, that's a difference of 2. I want to subtract 2 from both sides. So I'll go ahead and subtract 2 from, let's use a different color so it's clear. I'll subtract 2 from the x values of A, because 3 minus 2 is 1, and I want it to equal C. And what I do to one x value to the other x value, subtract 2 from the B as well. So that gives me negative 3 minus 2 is 1, negative 2 minus 2 is minus 4. So I'm allowed to do that. That works. Now I need to add another value. I need to add a value to the y values to make the y values the same. You can see that the x value is the same because A now equals 1, 1, and B equals negative 4, 6. So that A value aligns with the C value, and then B value aligns with the D value. We kind of want them to be the same thing. And so that's what we're trying to do here. Let's see if we can, what we've just done right now is we've translated A translated AB, the vector AB, 2 units to the left. And let's see if we can translate it down a few bits so that we can get down to CD. To do that, let's see, the difference between A and C and Y values, let's see, from 1 to negative 3, that's a minus 4. So I want to subtract 4 from both sides. I will subtract 4, subtract 4. So that gives us, let's see, so instead of having 1 and 6 now, we will have negative 3 and 2. And that's exactly what we want. So we got negative 3 is negative 3, 2 is 2. So that means I could, by subtracting some numbers from both x's and both y's, I was able to get the other sets of numbers. So that means that they are equivalent. The instructions that they give you in the online thing tell you to turn them both into component vectors. And if you want to do that, that works great. If it makes sense to you, awesome. But this works well for me. Let's move on to the second problem. The second problem says let P equal negative 2, 4, and Q equal 5, 7. Find the component form and the magnitude of vector PQ. Okay, again, a graph might be helpful here to kind of see what's going on. Let's go ahead and make our graph. And we have in our graph, let's see, our first value is -2, 4. I hope I'm not making it confusing by drawing very rough lines. -2, 4, that's P. Point Q is 5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, so that's Q. And we'll go ahead and we're drawing a line for PQ, for P to Q. So from P to Q, that is our line. Okay, so we want to find the component form and the magnitude of this. The component form is rather straightforward. We just need to make, well, maybe not straightforward, but once you get the hang of it, it's pretty simple. What you need to do is translate the graph so that P goes to 0. Okay, so right now we have P equals -2, 4, and Q equals 5, 7. I want P to become 0, 0. So here's what I'll do to do that. On the left side, I will translate it. On the x side, I'll translate it right 2 units because I need to get P to the right a bit. So I'll add 2, add 2. Whatever to do P, I have to do to Q. So we'll get 0 and then 7. And so P becomes in Q becomes that. And those just be arrows if that's confusing. I just made that more confusing. Oh well. I think you understand. Then for Q, for the y values, I need to take the y value of Q and make that to 0. So right now it's 4. I need to get rid of 4 to bring it back to 0. So I'll subtract 4 from the y side. Whatever I do to one y, I have to do to the other y. So they all work together. Again, I'm translating it down. That's how translation works. So subtract 4 from both sides, I get 0. And I get 7 minus 4 is 3. Great. So now if I have now that P is at 0, 0 and Q is at 7, 3, I know that the component vector is just that second value with greater than and less than signs, assuming that that our P is at 0, 0. Basically, here's all it means. The answer is 7, 3. And that's our answer. So that would be the component form of PQ. They're going to ask A, B. They'll say A, B, and we'll say A equals 7, B equals 3, but it's the same thing, so it's 7, 3. That's what's going on there. Now we need to find the magnitude of this number. And remember the equation we had for magnitude. We said that the magnitude, and then the magnitude is the same whether or not you're in component form or in the initial and terminal point form. Both of them will get the same because it's the same vector. It's just translated a bit. It's moved up, down, left, or right. If that doesn't make sense, don't worry about it. So the magnitude of V, remember this is not the absolute value of V, it's the magnitude of V, is the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the magnitude. And let's see, we have P and Q. So I'm gonna go ahead and label some values. Let's say P is our point number 1. Let's say, so P equals -2, 4, Q equals 5, 7. Let's say P is number 1, Q is number 2. Let's say this is X and this is Y. So let's see, X1 equals -2, X2 equals 5, Y1 equals 4, Y2 equals 7. Okay, and we just plug and chug. So magnitude of V equals the square root, of 5 minus -2 squared plus, let's see, y2 is 7 minus 4 squared. That gives us, let's see, 5 minus -2 is 5 plus 2, so 7 squared, which is 49. So it gives us a square root of 49 plus, let's see, 3 squared is 9. I'm going kind of quickly here because I want to save you time, but definitely feel free to do this on your own and kind of get the feel for it yourself, and try to get a feel for these numbers. So 49 plus 9 is 58, so magnitude of v equals square root of 58. And that is our answer, and that's the answer they're looking for up here. Okay, great. So that's those kinds of problems. Oh, it looks like I need to make more space. While I'm making more space, let's read the problem. It says we want to let q equal 2, 4, and s equal 1, negative 3. And it's asking, oh, that's messy. We'll deal with that later. It's asking, what is the component form and magnitude of 4 times qs? Okay, so let's kind of look at what's going on there. We said q equals 2, 4, and s equals 1, negative 3, and we're going to find the component form. So remember, first off, it's going qs. It's starting from q and going to s. So q is our initial, s is our terminal. So let's write that down. So we go from q to s. Q is number 1, and s is number 2. And we've got q equals 2, 4, s equals 1, negative 3. Okay, and from here let's start with, let's say we want to go to the component form first. X comma y. Let's just get the component form of qs first. Let's start with component of qs. You know what? Let's just make this simple on ourselves. Define the component form and magnitude. It's the exact same thing as what we've been doing before. Everything's precisely the same, except you multiply your answers by 4. So, for example, to save you time, let's say, for example, this is probably not what the answer actually is, but if the answer was, qs, let's say GD, just for the sake of showing these aren't the same numbers. If GD component equals 2, let's say 2, 3, then 4 times GD, we just multiply the numbers by 4. That's it. That's all we have to do. And we will take it and we will say component equals 4 times that. So that'd be 8, 12. That's all there is there. And same thing with the magnitude. If GD magnitude equals, let's say it equals 5, then for GD magnitude is exactly what you might expect. 5 times 4, which is 20. And that's all there is to it. So if there's a number beside it, multiply it through. That's all we need to know there. Okay, next one. Just trying to save you time here. Let u equal the components. Those are braces there. That's braces there. So that's the component form. U equal the component vector -6, 2, and w equal the component vector 4, -4. We want to find the component form of the vector u minus w and sketch a graph. Okay, so another the text here might seem a little more complicated than it is. Let's just kind of let me just show you what to do. Oh man, can I move that? I will try to move that. There we go. That's gonna look really messy. I'm gonna clean this up after the recording, so don't worry. The difference between the two vectors is we'll just subtract the two values. So -6, we'll just subtract the x's and subtract the y's. So we would say -6 minus 4 for the left side, and we would say 2 minus -4 on the right side. And that's all we have to do. -6 minus 4 is -10, and 2 minus -4, 2 minus -4, that's 6. So I'll write 6. Okay, and let me be clear on what we're doing here. Let me just make sure that the matchups are very clear. This -6 is that -6, this 4, let's use it color. This 4 is that 4, we match with the x's, and then we match with the y's because we're subtracting the ux's, and now we're going to subtract the uy's, or the ux and the wx. Now we're going to subtract the w, the uy from the wy. Oh my goodness, that's a tongue twister, or something. Maybe I just don't understand it well enough to be able to articulate clearly. Anyway, these are the things we're subtracting, and these are the values. So we just subtract the 2, and we get our answer. That's it. Okay, find the component form of the vector 2u minus 2v. Oh wait, when u is that and v is that. Okay, so we will take this is just about the same thing as before. It's exactly the same as before. You'll do the multiplication first, and then you'll multiply the -2 through first, and then you'll add them together. Simple as that. So, let's move that down. There we go. Okay, we start with this. We'll do -2u, and we're going to add to that a -2v. Let's make that clear. Okay, -2u, that just means you multiply all the values in u by -2. We're multiplying a vector by a scalar. If you want another terminology behind that, we're taking that scalar, just a number, -2, multiplying by the vector. Cool. So -1 times 3, or -1 and 3 times -2 gives us, that'd be 2 and -6. 2 6. Plus, and we're going to multiply 5 and 7 by -2, and we will get -10, so plus -10 and -14. And then we just add them together. Add the x's, add the y's, and we're done. So we'll take -2 plus -10 is -8, and -6 minus 14 is -20. And that's it. We're done. Okay, now let's move on to finding the component form of the vector v. We're going to solve algebraically and approximate the answers with a calculator. Okay, this is the last one, and it's probably the most difficult one, but I think you can do it. In order to really understand this, we just got to understand triangles. Okay, so they give us this graph that's a magnitude of 14. Its size is 14, and its angle, its direction is 25 degrees from 0. So, let me just rewrite this in a larger format so it's kind of easier to see what's going on here. We will take, and I can be pretty general here. I don't need to use exact tick marks on the graph. We'll do, I like green. Let's keep using green. We'll use 14. That's a big long, there's a 14 there. And then the angle is 25 degrees. And from here, here's where you might kill me for saying this, but we're gonna make a triangle, specifically a right triangle. Now, it's not as daunting as it seems. It's just a tiny bit of trigonometry here, so that's all we're gonna do. And just bear with me. Okay, so we've got two sides. We've got a right triangle. We want to find the component vector. We want to figure out the size. Really what we're trying to do, we know it starts at 0, 0. This starts at 0, 0. If we can figure out this point up here, this head of the vector, we can figure out what the component form is, because the component form is just braces, or sorry, not braces, it's that greater than and less than sign around, or less than greater than more accurately, around around that last point, that second point. So if we can just figure out what that second point is, that's all we have to do. So we got to figure out how far it is. If we can figure out the x distance, let's say this is x and y, we just got to figure out how far x is. And which is that same x. If we can figure out how high that point is, then we've got y. And we have the point itself, and that's all we need. We can plug that in and we'll be done. Okay, so find x. Let's see. We've got an angle, we've got a side, we've got the hypotenuse. And we're looking for that side. So what we need, we've got an angle, we've got the adjacent, and we've got the hypotenuse. And we're dealing with that, so we'll use ka, or cosine. So the cosine of 25 degrees equals x over 14. We'll simply simplify that. So 14 cosine of 25 degrees equals x, and we'll just plug that into our calculator and see what we get. I'm going to pull up my, that's not my calculator. Let's see if I can find my calculator. There it is. I thought I had it open. Oh well. We'll go to the, I want to make sure that I'm in degree mode. Yes, I'm in degree mode. That's important. And let's see, we had 14 cosine 25. So 14 times the cosine of 25 degrees. And that gives us 12.688. I think it's at around the 3 decimal places. Yeah, so it's 6 point, that's let me make sure I got that right. That's 12.688 is what we have. 12.688. Okay, so 12.688 is x, and we'll do the same thing for y. You can probably guess what we need to do here. We've got the opposite side, and we're looking for and we've got the hypotenuse, opposite side of 25 degrees, and we've got the hypotenuse. We're looking for that side, and so we'll use or sine. So sine of 25 degrees equals the opposite of the hypotenuse, equals y over 14. Multiply both sides of 14, so 14 sine 25 degrees equals y. And we'll plug that in. 14 sine 25, and that gives us a really nice 5.916. And let's see, rounding up to the 3rd decimal place, that's 5.917. So we'll go ahead and plug that in. 5.9117 is y. So that means that point then that we're looking for, that point, this is x and this is y. That means that the point we're looking for is 12.688 and 5.917. And that would be our answer. Cool. And that's the component vector. Cool. Again, if you're having any trouble at all, just let me know. I'm here to help you any way I can. I'll try to be available as often as possible. Just shoot me an email. I don't always respond to emails sometimes it takes me a little bit of time to respond to some emails. But if you say, hey, I need to work on something with you, I'll deal with that immediately. I'll drop whatever I'm doing to help you, because I want to make sure that you have whatever you need in order to get this done. So, with all that said, good luck. Let me know if you have any questions. I hope that was clear. If there's anything I can do to help make these things clear for you, just let me know. I'm here to help however I can. Thanks.